These are the notes for 2-2, solving one-step inequalities with addition and subtraction. First up, to solve an inequality, that means to find all of the values of the variable that solve that inequality. The method for solving inequalities is very similar to solving equations in that operations must be undone. Remember, to undo subtraction or a positive number, we'll subtract. To undo subtraction or negative numbers, we'll add. The first inequality, we have x minus 3 is greater than 9. So the inverse operation of subtracting 3 is adding 3. So we get x is greater than 12 as the solution. For the number line, we want 12 in the middle. We want to make sure we have at least 3 values on our number line. And we want to make sure our number line is increasing. 12 is not part of the solution set, so it will be an open circle at 12. And it's greater than, so we'll shade to the right. For number 2, on the side with the variable, we have negative 5 plus y. So to undo that negative number, we're going to add it to both sides, because negative 5 plus 5 is 0. That's how we isolate the variable. So we get 8 is less than y. Now, I always like to have my variable on the left for inequalities, and that helps with graphing as well. So let's read this inequality from right to left. Y is greater than 8. So when we rewrite, we'll write it as y is greater than 8. Keep in mind that if the inequality symbol is open towards the variable, we still want that to be true when we rewrite. Number line, put 8 in the middle. 8 is not included in the solution set, so we want it open at 8. It's all values greater than 8, so we want to shade to the right. For number 3, we have negative 9 plus x. So to undo that negative 9, we want to add 9 to both sides. And I get x is less than 5. For your number line, put 5 in the middle. Remember, we want 3 values. Open circle at 5 because it's just less than. Shaded to the left because it's less than. Remember, if your variable is on the right, if your variable is on the left, you can treat the inequality symbol like an arrow. For instance, greater than, less than. If you make this an arrow, it shows you which direction to shade. For 4, we have y plus 2 is less than or equal to negative 4. So the inverse operation would be to subtract 2. And we have y is less than or equal to negative 6. So be careful with making a negative number line because we want to make sure the number line is increasing, meaning going from least to greatest. So we want to be negative 7, negative 6, negative 5. Now this one is or equal to, so that means that negative 6 is included in the solution set. So it's going to be a closed circle. And it's all values less than negative 6, so we want to shade to the left. For number 5, on the side with the variable, it's 2 plus x. So to undo that positive 2, we want to subtract it from both sides. Now again, let's rewrite this so that the variable is on the left. So to do that, let's read the inequality from right to left. X is greater than or equal to negative 12. So we rewrite it, we'll write just that. X is greater than or equal to negative 12. Fill out your number line. Negative 12 is included in the solution set, and it's all values greater than or equal to, so we're shading to the right. For 6, on the side with the variable, we have y minus 7, so we want to add 7 to both sides. Now we want to rewrite this so that the variable is on the left, so let's read it from right to left. We have y is less than or equal to 14. So we're going to write just that, y is less than or equal to 14. So you can do it that way, or you can see that the inequality symbol is pointing towards the variable. So we want it pointing towards the variable when we rewrite. Fill out your number line. It's less than or equal to 14, so that means 14 is part of the solution set. And it's all values less than 14, so we're shading to the right. For these word problems, we want to write an inequality to model the situation and then solve. You have $2,000 saved for vacation. The airplane ticket is $637. We want to write and solve an inequality to find how much money you can spend for everything else. So let's think about that. What you spend versus what you have. What you spend has to be less than or equal to what you have, right? You can spend less money than you have, or you can spend all of your money, which is why it's less than or equal to. So what you spend, well, we've already spent $637. We want to find out how much more we can spend, so we'll add X. And this is less than or equal to 2,000. So there's our inequality that models the situation. And to solve, we'll subtract 637 from both sides. And we can spend at most $1,363. So we can spend that much money, or we can spend anything less than that. Suppose it takes no more than 25 minutes for you to get to school. If you have traveled 13 minutes already, how much longer at most might take to get to school? So we've already traveled 13 minutes. We want to find out how much longer, so we're going to add our unknown time. And keep in mind, no more than. That phrase means less than or equal to because I don't want to exceed that amount. So there's our inequality that models the situation, and we can subtract 13 from both sides to solve. So at most, you have 12 more minutes to go. That's it for the 2.2 notes on solving one-step inequalities using addition and subtraction.